Hey folks, and welcome to this video where I will explain to you what Terraform is, dive into some of its use cases versus other infrastructure as code languages, and share some example commands and files with you. Terraform is an open sourced infrastructure as code tool developed by HashiCorp. It allows you to define and manage your infrastructure resources as code, enabling you to automate the provisioning and configuration of your infrastructure. And it does this in a repeatable and scalable way. With Terraform, you write code in a declarative language that describes the desired state of your infrastructure resources, whether that is servers, databases, or networks in a configuration file. Terraform then uses this file to create, modify, or delete the resources needed to match the desired state, allowing you to manage your infrastructure as code. A wide range of cloud providers are supported by Terraform, including AWS, Azure, Google Cloud, and more, as well as your on-prem infrastructure. It has a large community of users and a vast library of reusable modules that make it easy to get started with infrastructure automation. In programming, there are two different programming paradigms, declarative and imperative. In a declarative approach in infrastructure as code, it focuses on specifying the desired outcome or state of a program, without necessarily providing the exact steps to achieve that outcome. With declarative programming, you define the desired state or configuration of a system or resource, and the system, the tool, takes care of determining the necessary steps to get there. For example, using a declarative approach in infrastructure as code, you would specify the desired configuration of a virtual machine. You would declare things such as its size, its operating system, and its software packages. You would then let your infrastructure as code tool determine the exact steps needed to create it. Terraform follows a declarative approach in infrastructure as code. In contrast, an imperative approach to infrastructure as code is that you specify the step-by-step instructions or command that program would execute in order to accomplish a task. This approach is much more procedural and tends to be more verbose, requiring the engineer to explicitly state every action that needs to be taken to achieve the desired outcome. For example, using an imperative approach, you would specify the commands to create a virtual machine, install the software, and configure its settings. Bash or PowerShell are examples of imperative languages. Declarative is often preferred in the infrastructure as code world because it can simplify the code and make it easier to maintain and scale, while reducing the risk of human error. Terraform and Azure Bicep are both infrastructure as code tools, and I often get asked about the comparison between the two. Both allow you to define and manage your cloud resources in a declarative way, but they have some differences in their approach and capabilities. Here are some key differences between Terraform and Azure Bicep. Terraform supports a wide variety of cloud providers, including AWS, Azure, Google Cloud, and more, as I said earlier. On the other hand, Azure Bicep is specific to the Azure cloud platform. Now, Terraform uses its own syntax and configuration languages, which may take some time to learn. Azure Bicep uses a syntax that is more familiar or similar to the Azure Resource Manager or ARM template language, making it easier for users who are familiar with ARM templates to get started. Terraform has a larger selection of resources that supports it, including some third-party resources. Azure Bicep, on the other hand, is focused exclusively on Azure resources. Now, both languages have a fairly large and active community of users and contributors. I think overall, though, Terraform may be slightly larger just because it is an older tool and Azure Bicep is slightly newer. Terraform has several advanced features such as support for remote state management and dependency tracking that make it a well-suited tool for managing large-scale and complex infrastructure deployments. Azure Bicep, on the other hand, is designed to simplify the process of authoring ARM templates and make them more readable and maintainable. Overall, though, both Terraform and Azure Bicep are powerful tools for managing cloud resources as code, and the choice between them will depend on your specific requirements and use case. So what is Terraform used for? There are some common use cases for Terraform. Terraform allows you to define your infrastructure as code, making it easier to provision and manage your resources across different platforms and potentially different cloud providers. It's also great for being able to reuse and replicate your environments. So the Terraform code that you create for, say, your staging environment can be reused in your dev environment, in your production environment, and it helps to really manage your resources and keep on top of exactly the configuration that you need for them. So how does Terraform work? What is the process and the steps that it goes through to deploy your infrastructure? So first of all, you define your infrastructure resources in a configuration file using the HashiCorp configuration language, HCL for short, or JSON format. Inside this configuration file, you declare the infrastructure resources you want to create and configure, such as virtual machines, databases, load balancers, or your network configuration. When you run the Terraform apply command, Terraform runs the configuration file and creates a dependency graph for the resources you've defined. It then compares the desired state of your infrastructure with the current state and identifies the necessary changes to achieve the desired state. Terraform then provisions the necessary resources to create and configure your infrastructure. It communicates with the API of your cloud provider or on-prem infrastructure and then creates and manages the resources. Terraform manages a state file that tracks the current state of your infrastructure, and this helps it perform updates, rollbacks, and other operations as necessary. As your infrastructure changes, you can update your configuration file and run Terraform apply again. Terraform will determine the changes necessary to your infrastructure and apply them in a safe and controlled manner. It's ultimately an iterative process when you're looking to use Terraform to manage your resources. Here are the top 5 Terraform commands that are commonly used and ones that are key as you begin your learning journey with Terraform. Terraform init is the command that initiates a new Terraform project and downloads any necessary plugins and modules, setting up the working directory for Terraform. Terraform plan is the command that creates an execution plan for applying changes to your infrastructure, showing you what actions Terraform will take and any potential errors or issues. We then have Terraform apply. This applies the changes to your infrastructure as defined in your Terraform configuration file, creating, modifying or deleting resources as necessary. Now this is a handy command, Terraform destroy. It destroys all the resources that were created by Terraform, allowing you to tear down your infrastructure. Lastly, we have Terraform validate. This command validates the syntax and configuration of your Terraform files, checking for any errors or issues before running any Terraform commands. These commands provide the essential functionalities of Terraform, allowing you to initialize your project, plan and apply changes to your infrastructure, and validate your code. There are other commands available inside Terraform that can help you with tasks like importing existing infrastructure, managing the state, and working with modules. Taking a look at some Terraform example files here, we've got one that will deploy resources to Azure. This section indicates that you want to use the Azure provider and what version of that provider you are going to use. The next section starts to define a resource, and in this case it's the deployment of an Azure resource group. A Terraform file for AWS is very similar. We have a section indicating we are going to use the AWS provider and what version we need to use. It also has a section where we define the AWS region we are going to use when we are deploying our resources. I hope this video has given you a good high-level overview of Terraform and how it works. If you want to learn more, subscribe to my channel and stay tuned for more videos. See you in the next one.